What if I told you that SpaceX just completed one of the most ambitious rocket tests in human history? A 120-meter-tall mega rocket, literally taller than the Statue of Liberty, traveling at speeds over 25 times the speed of sound. With engines so powerful they can generate 33 million pounds of thrust. This is Starship. And what happened during its fifth flight test just changed everything we know about what's possible in space exploration. Stick around as we break down what makes Flight Test 5 absolutely game-changing for the future of humanity in space. Hey everyone, welcome back to the channel. If you're new here, don't forget to hit that subscribe button, because we dive deep into the latest space exploration breakthroughs every single week. So here's the thing, Starship isn't just another rocket, it's humanity's answer to a fundamental question: how do we become a multi-planetary species? And on date of Flight Test 5, we got closer to that answer than ever before. Today we're covering exactly what happened during Starship's fifth integrated flight test, why it matters so much, and what it means for the future of space travel. Let's get into it. Before we talk about Flight Test 5, we need to understand what we're actually looking at. Starship is SpaceX's fully reusable super heavy lift launch vehicle. That's a mouthful, so let me break it down. Think of Starship as the future replacement for the Falcon 9 rocket that's already revolutionized the space industry. But Starship is designed to be way bigger and way more powerful. We're talking about a vehicle that's 120 meters tall, that's about 394 feet. To put that in perspective, the Eiffel Tower is 330 meters tall, but Starship would only need to stack less than half of them together to match that height. It's absolutely massive. The Starship system has two main components. Number one, the Super Heavy Booster, the first stage. This thing has 33 engines called Raptors, 33. Each one generates roughly 500,000 pounds of thrust. Combined, they produce 33 million pounds of thrust at sea level. For comparison, the Saturn V rocket that took humans to the moon had 7.5 million pounds of thrust. Starship's booster alone is more than 4 times more powerful. Number 2, the Starship upper stage. This is the vehicle that will carry cargo or passengers to orbit, the moon, Mars, and eventually beyond. It has 6 Raptor engines and can carry up to 150 metric tons to low Earth orbit. But here's what makes it truly revolutionary. It's designed to be fully reusable. Both stages are meant to land themselves, be refueled, and launch again within hours. We're not talking weeks or months, we're talking hours. SpaceX already proved reusability is possible with the Falcon 9, but Starship takes it to a completely different level. Now, getting Starship to Flight Test 5 wasn't exactly smooth sailing. Let's rewind and see where we came from. In April 2023, Starship had its first integrated flight test, Flight Test 1. The Super Heavy booster actually launched successfully, but the vehicle experienced an uncontrolled disassembly during ascent. In space terms, that's a nice way of saying it exploded. But here's the crazy thing, SpaceX celebrated. Why? Because even in failure, they learned. Engineers analyzed every millisecond of data. Flight Test 2 happened in November 2023. Better performance, but still ended in failure during the second stage. Flight Test 3 in March 2024. This was huge. For the first time, Starship reached space. The vehicle broke up on re-entry, but they were making progress. Flight Test 4 in June 2024 was even more dramatic. The booster successfully performed its first boost back burn and achieved a controlled splashdown in the Gulf of Mexico. Meanwhile, the Starship upper stage achieved controlled re-entry and a soft landing in the Indian Ocean. Each test, they were checking off milestones that everyone said would take years to accomplish. But SpaceX has a different philosophy. They test fast, they fail fast, and they iterate faster than anyone else. So by the time Flight Test 5 rolled around, the bar was already incredibly high. All right, here's where it gets really interesting. Flight Test 5 took place on a specific date, and it was absolutely phenomenal. Let's break down what made this flight test historic: the launch. The massive Super Heavy booster ignited all 33 Raptor engines in a stunning display of controlled chaos. The ground shook, literally. People watching from miles away felt it. This thing generated 33 million pounds of thrust. The booster lifted the entire Starship stack off the ground and accelerated it to speeds exceeding Mach 25. That's 25 times the speed of sound. We're talking about 17,500 miles per hour. The booster catch. Here's where Flight Test 5 made history. For the first time ever, the Super Heavy booster didn't just land. It was caught by the launch tower's mechanical arms. I need you to understand how insane this is. Imagine a 33-story building made of steel, weighing thousands of tons, traveling at supersonic speeds, and someone literally catches it with giant mechanical arms. It sounds like something out of science fiction, but SpaceX just did it. Those mechanical arms, called chopsticks, are attached to the launch tower and essentially pluck the booster out of the sky. This is revolutionary because it means 1. No expensive floating barge needed. 2. The booster can be ready for the next launch incredibly quickly. 3. Turnaround time goes from weeks to days. Elon Musk didn't shy away from calling it what it was, one of the most important moments in rocketry history, the Starship upper stage. While the booster was being caught, Starship continued its ascent. The upper stage separated, fired its engines, and achieved stage separation, which means the booster and upper stage successfully parted ways. The Starship then performed a series of increasingly sophisticated maneuvers. It executed engine burns, demonstrated attitude control, and showed that the vehicle can perform the complex choreography required for space missions. This flight test also marked the first time Starship completed a full engine startup sequence in space. That might sound like a small technical achievement, but it's actually massive. It proves the engines can be restarted in the vacuum of space, which is essential for orbital refueling, lunar missions, and Mars missions. The re-entry and splashdown. As Starship descended back toward Earth, it performed a controlled re-entry through the atmosphere. The heat shield held. The vehicle maintained its orientation, and then it executed a controlled splashdown in the Indian Ocean. That's not an uncontrolled crash. That's a precision landing where we're learning exactly how to bring this massive vehicle back to Earth safely. Okay, so why should you care? Why does Starship's fifth flight test matter beyond just watching cool rocket videos? Well, it matters because Starship is the key to several things humanity is desperate to accomplish: lunar exploration. NASA selected Starship as the vehicle that will land astronauts on the Moon as part of the Artemis program. Not as a backup option, as the primary choice. Why? Because nothing else can do what Starship can do. The Moon isn't just about flags and footprints anymore. We're talking about establishing a permanent human presence on the lunar surface. That requires a vehicle that can deliver massive amounts of cargo and scale up operations. Starship is that vehicle. Mars colonization. Elon Musk's stated goal is to make humanity a multi-planetary species. That requires affordable, reliable access to space. The Falcon 9 was a huge step in that direction, but Starship is the solution to getting humans to Mars. Think about it. A fully reusable vehicle that can make the journey to Mars and back, that can be refueled in space. And that can carry 100+ people. That's not science fiction. That's what Starship is designed to do. Space station resupply and orbital logistics. Currently, resupplying the International Space Station is expensive and complicated. Starship changes that equation entirely. With rapid reusability, you could launch cargo to orbit dozens of times a year from the same hardware. That drives down costs, increases frequency, and enables entirely new possibilities for space commerce. Space tourism. Starship isn't just about exploration, it's about access. SpaceX has already announced plans for crewed missions around the Moon on Starship. Imagine taking a trip to space, seeing the Earth from above, traveling around the Moon and returning home, all in the same vehicle. This was previously impossible without spending $1 billion. Starship changes that. Challenges ahead. But here's the thing, we're not there yet. While Flight Test 5 was an incredible success, there are still major hurdles to overcome. Heat shield development. The external heat shield that protects Starship during re-entry needs more work. It's taking damage that needs to be repaired. SpaceX is actively developing better materials and more durable solutions. Landing systems. Catching the booster is amazing, but we still need to nail the precision landing for Starship itself. Controlled splashdowns are progress, but eventual land landings are the goal for true rapid reusability. Regulatory approval. Getting FAA approval for Starship to launch is a process. Environmental concerns, safety protocols, and international space law all need to be satisfied. Scale and cost. While Starship will be cheaper than existing systems, the development and manufacturing cost remains enormous. SpaceX needs to prove the business case works at scale. But, and this is important, every single one of these challenges is engineering problems, not physics problems. SpaceX has a proven track record of solving engineering problems that everyone said were impossible. What's next? So what does the future hold? SpaceX has announced plans for Flight Test 6, which will push reusability even further. They're working toward the first booster refly, that is, launching the same booster twice. That's the key metric that proves this whole reusability concept actually works economically. By 2026, we could see Starship launching regularly, with both the booster and upper stage landing successfully, and being ready for the next launch within days. By 2027-2028, SpaceX is targeting the first crewed missions around the Moon with Starship. The long-term vision is even more ambitious, establishing a fuel depot in orbit, enabling moon bases, and eventually sending humans to Mars. All of this traces back to moments like Flight Test 5, where we prove the technology works and identify what needs to be improved next. So here's the bottom line. Starship's fifth flight test wasn't just another rocket test. It was a statement about what's possible when you combine brilliant engineering, relentless iteration, and the vision to actually pursue transformative goals. We're living in an era where mega rockets are being caught out of the sky, where companies are building vehicles designed for Mars, and where space is becoming genuinely accessible for the first time in human history. If you're interested in where humanity is headed and the technology making it possible, you need to stay tuned, because we're literally at the beginning of a new era in space exploration. So what do you think about Starship's progress? Are you excited about the possibilities for lunar bases and Mars missions? Or do you have concerns about the rapid pace of development? Drop your thoughts in the comments below. I read every single one. If you enjoyed this deep dive into Starship and the future of space exploration, please give this video a thumbs up. Hit that subscribe button and ring the notification bell so you don't miss our next video breaking down the latest in space technology. Thanks so much for watching, and I'll see you in the next one.